Okay, we're going to look at this part first. Find a formula for g of t. Let's assume that it's an exponential function, which means it looks something like that. And the two pieces of information that they give us, you could kind of think of as being in a table. When t is 0, the number of grams initially is 316, and when t is 195 minutes, there's only 4.9375 grams of the goo remaining. So if we let t equal 0 and g equal 316, we can solve for a. That's the initial value, 316. And now we can use this piece of information to find out the value for this base. So when t is 195, the number of grams is 4.9375. Divide both sides by 316. Then take the 195th root of that number to get what the base is. And that's the same as raising this to the 195th power, 195th power. And there's your value of b right there. And if you want to rewrite the formula or the function in terms of a base of e, you kind of use this property of logarithms. E to the ln of anything is the anything. So if you rewrite this b to the rewrite the b as e to the ln of b, then here's b raised to the t power. You can picture multiplying power of a power, e times ln of b. And there is ln of b right there. We usually use the letter k, or that's one of the letters you can use. So if k is negative 0.02137, there's another way to write g. Okay, so either of these, depending on what base you want to use. To get the half-life, we want to know when the initial value has decayed to half of what it started with. That would be 158. How do I solve for t? Divide by 316. 158 divided by 316 is a half. Take the natural log of both sides. The property of logarithms to move this t down front. And then t equals ln of 1/2 divided by ln of b. Well, we already know that ln of b is this value of k. So when you have it in this form, all you have to do is divide ln of 1/2 by that value to get the half-life. And on board 2, looks like the half-life is 32.5 minutes. That means every 32.5 minutes, the amount of goo goes down by half of what it was. Here is g of h sub 1. That's 158. That's half of the 316. But here's another example. At g of 7, there's this much goo left. And 32.5 seconds later, there's half of what was left. And finally, here's your answer to g of 17. Just plug in 17 into the function to get the number of grams of goo remaining. Okay, there you go. Hope that helped. If you have any questions, post a comment.